Hi calculus students, this is recovery video 2. There's also, I think, 3 partner problems that correspond to this video, which you should watch before you do them. What is a definite integral? So recovery video 1 was on indefinite integrals, which essentially, indefinite integrals just essentially mean the antiderivative of whatever the input is. But a definite integral means something entirely different, but the notation looks almost exactly the same. So what is a definite integral? You've got a definite integral when it looks like this. Notice the only difference between a definite integral, which is right here, and this was from video 1, an indefinite integral looks like that, is that the definite integral has what we call a lower limit and an upper limit. Okay, so it has numbers at the bottom and top of the integral sign. And what is the meaning of a definite integral? A definite integral does not mean the antiderivative. It means the area under the curve of the input. And curve is another name for graph. So the area under the graph of the input, and it has to be on a certain interval. So on the interval that starts at the lower limit and ends at the upper limit. So it doesn't mean the antiderivative. This does not mean the antiderivative. This means the area under the curve. But the reason why people talk about the antiderivatives and area under the curve, the reason they talk about them lots of times simultaneously is because in order to find the area under the curve without a calculator, you have to find the antiderivative. Okay, that's the fundamental theorem of calculus. So part C, use a definite integral to represent the area under the curve of this function on that interval. So I'm going to, so this interval from -3 to 10 dx, okay? And then the input, so this represents the area under the curve of whatever function goes in here on that interval. And the function that I want to go in here is 2x plus 3. Okay? So this definite integral represents the area under the curve of this function on that interval. Okay? Now evaluate the definite integral to the left, and this is where it gets kind of confusing. This does not mean the antiderivative, but the fundamental theorem of calculus says that we can, if we take the antiderivative of it, we can evaluate this integral. So this definite integral. So over here, so in this part, evaluate the definite integral to the left. All right, so equals this stuff over here. So when you're evaluating a definite integral without a calculator, if I were you, I would do it just like this. You open up some blank brackets. You put your limits of integration at the end of the brackets. Okay, upper limit up there, lower limit down there. And then what goes inside of this bracket is the antiderivative of that input. Okay, so the antiderivative, I add 1 to the exponent and then I divide by it, so I end up with x squared plus 3x. All right? Now this is like an intermediate step. What this step does is it gets us ready to actually do the computation that gives us the area under the curve. And the way we do it is first we plug 10 into the antiderivative, so we're getting 100 plus 30. So 130 when you plug in 10. And then you subtract what you get when you plug in the lower limit. So if you plug in -3, you get 9. Oh, goodness. You get 9 plus -9. You just get 0. And then you get 130. So that is the area under the curve. Okay, so fill in this blank. The input of a definite integral is a... What did we put inside? What did we put inside of that definite integral? We put a function. And let me flip to recovery video 1 because the input of an indefinite integral is also a function. All right? The output, this was from yesterday, so the output of an indefinite integral is the antiderivative of the input, but not the case with a definite integral. For a definite integral, the output of a definite integral is the area under the curve of the input. Okay, so the antiderivative is not the output. We have to take the antiderivative to find the area under the curve. That's the fundamental theorem of calculus that we're using there. But it's a different concept entirely that is the output. Okay, guys, I hope that this is helpful. You're going to do a few exercises just like this, hopefully to solidify the difference between these two things. And I will see you soon. Bye-bye.